If I have an acute angle, I can put it in a right triangle, I can see opposite, adjacent, hypotenuse, I can figure out the trig function values, and I can look at it and relate to it. If I have an angle that's bigger than an acute angle, so one that's in quadrants 2, 3, or 4, it's a little bit harder to do that. The idea of reference angles is going to pull everything back to acute angles and right triangles. It makes it a little easier to draw a picture and see what's going on. If I have an angle in quadrant 2, so terminal side is in quadrant 2, like say, what's in quadrant 2? The 123 degrees. And I want to know trig function values, and I'm stranded on a desert island without my calculator. That's not even something that I could put into a right triangle. So like math people like to do, I'm going to make it work. I'm going to draw a right triangle. I'm going to draw perpendicular to the x-axis. 100% of the time it's the x-axis that I'm using. Y does not get to play this game. I'm going to draw my reference triangle using the x-axis. Now I have, well, my 123 degree angle isn't inside there, but I do have this angle inside there, and I can figure out what that is, because if I went all the way from the positive x-axis around to the negative x-axis, that's 180 degrees. But if I want the part that's inside the triangle, I don't want all of that. I can subtract off my original 123 degree angle and get just the red part, which is the difference between 180 and 123. So if I have an angle in quadrant 2, I'm going to call this red angle inside here my reference angle. And I can find it by subtracting 180 minus 123 degrees to get 57. My reference angle is 57. The trig function values of 123 degrees are all the same as the trig function values of the 57 degree reference angle. That's acute. You can put it in a right triangle. In general, reference angles in quadrant 2 I can find just like this, 180 minus my original angle, or if you happen to be in radians, 180 is pi radians minus my original angle. Okay, great. What if I'm in quadrant 3? So suppose I have an angle in quadrant 3, like, 227 degrees, which I really wrote on the wrong side because that's over here. Again, I'm going to draw a reference triangle. Really need the arrow. Using the x-axis. The x-axis. I'm going to draw to the x-axis. There's my right triangle. And now I have this little angle inside the triangle. That's going to be my reference angle for my 227 degree non-acute angle. Well, I can't find that by subtracting 180 degrees minus theta. If I do that, that's going to be a negative number because theta is already bigger than 180. But I could do the other way around. If I say my entire angle is 227, and I subtract off quadrants 1 and 2, we'll just get rid of those that aren't part of the triangle. That'll leave me with the part that is inside the triangle. So for angles in quadrant 3, I can find a reference angle by subtracting my original angle minus my original angle is 227, minus quadrants 1 and 2, 180 degrees. Here, that gets me 47 degrees that are inside the triangle. So my reference angle is 47 degrees. All the trig function values of 47 degrees are the same as the trig function values of 227. In general, in quadrant 3, I can take my original angle and subtract off quadrants 1 and 2, 180 degrees, or pi radians. In quadrant 4, we'll do something similar. We just got to see how everything relates here. If my angle's in quadrant 4, say 321 degrees. I'm going to draw a reference triangle using the x-axis, right triangle, there it is. My reference angle will be the angle inside the triangle. Everything disappeared for a second there. There's what I'm looking for. This time, I'm going to notice that if I went all the way around, I would have gone 360 degrees, but I'm not going to do that. I'm going to stop before I get there. So 360 degrees minus my original angle leaves just the part inside the triangle. In general, in quadrant 3, I can find a reference angle by taking my original angle and subtracting it from 360 degrees. So 360 minus 321, I get 39. So the part inside the triangle, my reference angle is 39 degrees. In general, for quadrant 3, I can take 360 degrees minus my original angle, or if you're in radians, 2 pi minus the original angle.